Alrighty folks, so we'll talk about weather maps and we'll start looking at isobars, which are basically contour lines for weather. So we've covered already in the last video air pressure. So air pressure moves from areas of high pressure. It always wants to balance itself out to move to areas of low pressure. So if we have a parcel of air that's hot, it's high energy, it's being heated up by the sun, could be in the oven, could be on the stovetop, whatever, it's being heated up and it's becoming areas of high energy and high pressure within that air cell. We have areas of low pressure where it's cooled down, the same heat energy isn't applied to it, so that becomes much more chill. Air always wants to flow from areas of high, wants to equalize out across the atmosphere and wants to travel to areas of low pressure. So high energy moves out, low energy moves inwards. And this is how we have the transfer of energy across the atmosphere and the transfer of heat and how weather systems work. So we covered that yesterday in the last video. So we'll just cover contour lines and isobars. So contour lines, we know, just to recap, we have concentric circles that join equal areas of height, with the middle being the highest and the outside being the lowest. The steeper the gradient is determined by how close together these lines are. So the closer the contour lines, the steeper that hill is. And the gradient always flows from the inside at the knoll, at the top of the hill, out to the low side, to the bottom of our hill. Our contour lines on our isobars on a weather map work the exact same, of areas of high pressure. Again, following the principle from above, areas of high pressure want to flow from the inside and they want to push outwards. However, our low pressure systems look exactly the same with isobars. However, the lowest area of pressure is actually in the middle of that pressure zone. So it wants to flow inwards. The area of height goes from outside inwards. On a high, it goes from inwards out. Low pressure, it goes from outwards in. Same principle applies. The steeper the gradient, the steeper the contour lines, the steeper the isobars. On a contour map, we have reference lines that tells the height. Here we have reference lines that tell the pressure, usually in hectopascals. So that would be about 1,000, with the middle usually about 980 hectopascals. The greater the difference between here, so that's 1020 hectopascals to here, the greater the difference between the middle of these two zones is, the faster the wind moves from the center of the high pressure zone here outwards towards the inside of the low pressure system. So that's the basics of weather maps. It's really important that we understand that air moves from the inside of high pressure outwards and the outside of low pressure inwards, because this creates how wind and how it moves and how it generates, which we'll talk about rotation, and we'll talk about how the air moves in a second. So it's just really important to understand that a high pressure zone looks like this, and a low pressure zone is the exact opposite and looks like this. So air moves from up here right down to here. This is the top of our isobar line here, and this is the bottom of our isobar line here for high to low. Great, next video we'll talk about what it actually looks like over top of a weather map.